Alright, so this is the questions for the final physics test part 2. So I created the chart that you can see here. I also expanded the numbers so we have more to work with to give us a final, more exact number. Here's the chart that I used. So I started with using my 4,312 and I divided it by 2. And once I took 4,312 divided by 2 to get me a slope from my graph, that gave me 2,156. Using that number, I can use this equation from the chart that it gave us, and I can find the x value because it wasn't part of the data plot, so we have to find it ourselves. So from there, it's 2,156 equals the 3,492. I'm going to keep all the decimal places for an exact number at the end, so 0.0802416 raised to the negative 0.0046802x. Then I would divide the whole thing by 3492.08, all these numbers down here, and that gave me e raised to the negative 0.0046802x equals, I divided that to give me 0.617397036. Then I would take the natural logarithm from both sides. And then from there, I can just divide, but first, let's do this first. So we go is negative 0.00466802, and then that would be our x, the natural logarithm e equals natural logarithm for our whole number here, 0.617397086 here. Then I can divide by negative 0.00466802, and then this would just be 1. So that leaves me getting rid of this side and leaving x isolated on the other. And then the natural logarithm of 0.617 is approximately 103.0389649, or our x value would be approximately 103 seconds. Then converting that to minutes, it would leave me with 103 seconds times 60 seconds to 1 minute. That would give me about 1.7 minutes. Then comparing that online, the closest isotope I could find was barium-122. About 1.95 was the closest one I found. So barium-122, according to online, goes through a beta plus decay. So in that case, it would change by 1 and it emits or loses 1 proton. So that would leave you with 122 cesium. So that is what we have for the final answer. Thank you. That's it.